mathematical ideas. Okay, so some of the technical terms that we use in math is used differently in, for example, in English. Okay, so we say the mathematical language is precise. Yeah, it needs to be precise. Okay, so it needs to be correct all the time. Okay, even if the answer is not sure, then okay, we should have a way of making sure that it is precise, that the answer is not sure. Okay, uh, it's highly symbolic language. Yes, we made use of different symbols, and in a dialectic manner allows for adaptation, adjustment, and cumulative refinement of concepts. Okay, it is also concise, right? So a whole statement, a very long sentence, can just simply converted into a few samples. Okay, so for example, the famous Pythagorean theorem, right? Okay, so if you are going to state the Pythagorean theorem, okay, it's composed of several words, right? But if you just simply say the Pythagorean theorem is equal to a squared plus b squared is equal to c squared, right? So in symbol form, okay, you have only how many symbols there, okay? But in word form, that will be long. We would say the Pythagorean theorem states that the square of the uh, of the width, okay, or the square of the two sides of a right triangle is equal to the square of the hypotenuse. All right. So it's we use symbols. It's concise. At the same time, it is precise, and it follows that it is now powerful. Okay, because it's a way now of expressing thoughts with relative ease. Okay, so for example, the famous formula of Albert Einstein, E is equal to mc squared, right? Okay, very simple formula, but the effect of that has a great impact around the world. Okay, so Galileo Galilei said, mathematics is the language in which God has written the universe. Okay, so it's up to you how to interpret that. Okay, it's up to the interpretation of God. Okay, God could be a being or it could be an infinite intelligence. Okay, it's up to you how to interpret that. But um, the what he's trying to say here is mathematics is the language, meaning to say, okay, it could be in another form. Okay, um, the Hindus, for example, and then the Egyptians, and then the Mayans. Okay, they may speak different languages. Okay, but when it comes to building structures, okay, they could have something in common, and that is the language of mathematics. Okay, so um, what are the basic concepts that we incorporate in the mathematical language? Okay, so first, of course, is your expression. Diba? You talk about this when you were in junior high school. So a mathematical expression or just simply an expression. Take note again, the difference, okay? In your English subject before, English 101 or 201, when you say expression, it means a different thing in the English language. But in mathematics, when you say a mathematical expression, it is just simply a combination of symbols, okay, that is well defined, okay? It could be a composition of numbers, it could be variables, operations, functions, grouping symbols, and other punctuations. So you have an example here, 56, 6 minus 4y, a squared plus b squared. Okay. So of course, it doesn't have a complete thought, okay, because it's just an expression, okay. Now, to complete the thought, we should have what we call a mathematical sentence. Okay. So in a mathematical sentence, we make a complete statement about two expressions. So here, we are going to see now the relationship of two expressions. Okay. So it could be a combination of a variable of numbers or a combination of both. Okay. It can use words like equals, greater than, or less than. Okay, so we had an example here. 50 plus 6 is equal to 56. So in this case, we call this a mathematical sentence because what we are saying is the value on the left is equal to the value on the right. Okay, so there's a complete thought. But if we just simply say 50 plus 6, that is just an expression. Same thing, when we say 6 minus 4y is greater than 18, then we are now saying that the value on the left is greater than the value on the right, or the value on the right, 18, is less than the value on the left, or the expression on the left, which is 6 minus 4y. All right, and same thing with a squared plus b squared is equal to c squared. There is now a complete thought. Okay, variables. Okay, I hope by now the meaning of variables is already clear to you. Okay, so in mathematics, we always use variables. What's the purpose of using the variable? Okay, so when we use a variable, okay, it serves two purposes. One, okay, it has one or more values, but we don't know what they are. Diba? Ayan yung sa math. We don't know your age, for example, but we can assign a variable to your age. Okay. So let's consider, for example, art. Mhm. So I don't know the age of art, but I can just simply assign a value to the age of art. Okay. So if I say uh, X is the age of art, which is higher than the age of, let's say, Billy. And I can also assign a variable with the age of Billy, for example. Okay. So in mathematics, that's what we do. We assign a variable to values that we don't know. Okay. The other situation in which we use the variable is you want whatever you say about it to be equally true for all elements in a given set, and so you don't want to be restricted to considering only a particular concrete value. Okay. So same manner, okay, I may not be sure with the age of art, okay, but I know that the age of art is a positive number. Okay, so in that case, okay, I'm not restricted to only one number, okay, but that number includes the set of positive numbers. Okay, so other examples here. Is there a number with the following property? Doubling it and adding 3 gives the same result as squaring it. Okay. A mathematical statement. Okay. Let's use variables. Okay. So it says here, let's try to analyze this statement here. Okay. Is there a number with the following property? Doubling it, you double it, and you add 3 gives the same result as squaring it. Okay. Alright, so that's a mathematical sentence. Okay. Now let's convert this one now, okay, into another mathematical statement, but this time we are going to use variables. So we say, is there a number x? So we number. Is there a number x with the property that, what is the property? Doubling it. So how do we double it? Diba, we multiply x with 2, right? 2x, that is doubling it, okay? And adding 3, that is plus 3. Okay, let me underline that twice. Gives the same result as squaring it. Squaring it. Right? Okay. So from this mathematical statement, we converted it to another mathematical statement, but this is more formal. Okay. And we made use of variables. Right? Okay. Okay. For a while.